Hello students, I am Kausalya and today we are going to discuss about mechanical systems. So the mechanical systems are broadly classified into two types. One is translational system and another one is a rotational system. A translational system is one which moves in a flat path. That is, a translational system is one which moves in a straight line. Either the force applied may be a push or a pull. The best example is just moving a box on the ground. Just by pushing, by giving a push force, we are moving a box on the ground is a translational system. That is, the element initial position will be this. Just by after applying a force F, this box will have some displacement and its final position is this one. So whenever a force is applied and when a body moves in a straight line, then the respective system is known as the translational system. And the second one is rotational system. A rotational system is one which always rotates with respect to a reference point. So here for example, just consider a fixed point here and to which here we have attached a door. So whenever this door is given a push or pull, automatically this door will rotate with respect to this reference point. And this is the example for a rotational system. So in other words, regarding translational system, we will measure the displacement in terms of that is meters, centimeters or whatever may be. Whereas in the case of rotational system, the measurement is always with respect to some reference angle. Theta, right? And now we are going to see about elements in mechanical translational systems. So regarding elements, this system has three basic elements. The first one is mass and it is represented by a box with the letter M inside, and mass is nothing but, as we all know, it is measured in terms of kg. It is just nothing but a weight, that's it. And the second one is spring. Here the spring, this is the symbol of the spring. In other words, it is nothing but just like an elastic band. We can either stretch or compress. So the spring and its notation is K here. And the third one is dashpot. Here dashpot is represented by the symbol. It is denoted by B and it is drawn like this. And here dashpot is nothing but friction which is experienced by the mass or a weight. So here in this case we are having mass M here, and whenever we are giving a force like this, automatically this mass moves to this position. So whenever the mass travels through this path, automatically it will experience some frictional force, and this friction is denoted by this word dashpot, and the symbol is B here. And the next one is the basic symbols which are used in the mechanical translational system is, as I already said, it is that is the displacement is in a straight line. That is the movement is in a straight line. So here we are considering x. This x is nothing but displacement and it is measured in meters. And the second one is velocity. As we all know, velocity is nothing but displacement by time. So dx by dt, and it is unit is meter per second, that is distance in meters and time in seconds. And the next one is acceleration. So acceleration is nothing but that is dv by dt. Whenever the velocity is differentiated with respect to time, we will get acceleration, or in other words, whenever acceleration is represented in terms of displacement, we have to write it as d square x by dt square, and again here the unit will be meter per second square. And here these are all the normal terms which we will be using while solving the problems. And here F is nothing but applied force, and again the unit of force, as we all know, it is in Newton. And the second one is Fm. Here Fm is nothing but opposing force due to the mass m. That is, whenever a force F is applied, just consider this basic diagram. Whenever a force F is applied to a mass m, automatically this own mass will produce some opposing force, right? So that opposing force is denoted by the letter Fm. And the next one is, whenever again consider the same thing, and whenever we are applying a force F, this mass will move some distance, right? From this initial position, at least consider, let it be the initial position. Whenever the force F is applied, it will move a little bit, right? Let this be the final position. So whenever it moves from this position to this position, automatically due to the friction of ground, that is the friction will exist here. So the friction will provide some opposing force, and that opposing force is denoted by the letter FB. So FB is nothing but opposing force due to the friction, or the material here is, we are representing it as friction as dashpot. So opposing force due to dashpot, and it is given by the symbol B. And the next one is, here we are having a spring which is attached to the mass M. So whenever a force F is applied to the mass, automatically the string will get disturbed, right? Since it is connected to the mass. So this spring will also provide some opposing force, and that opposing force is denoted as Fk, and the symbol here is K. And the next topic is force balance equations. Only when we know the force balance equations, it is easy to find out the transfer function for a given system. So here the force balance equation for analysis, first I am considering the mass M. So to the mass M, here F is nothing but the applied force. So whenever a force is applied to whatever may be the material, it will surely exert some opposing force. So here Fm is the opposing force which is given by mass M, and X is the displacement. And now we are going to represent in terms of force balance. So here in this case, the opposing force given by mass M is directly proportional to the acceleration. Here the distance is x. So whenever we want acceleration, it is represented as d square x by dt square. And here the proportionality constant is, again we are having this same, because this is due to the mass M. So the proportionality constant here is M. So Fm is given as M into d square x by dt square. And finally, whenever this is the basic concept, the applied force is always equal to the opposing force. So here we are representing F is equal to Fm, and which is equal to M into d square x by dt square. This is just we are following the Newton's second law. So as we all know, Newton's second law is given by F is equal to ma. So here m, and this is nothing but the acceleration. And the next one is, we are going to discuss about the spring here, and to the spring again we are having a applied force F, and the respective displacement is x. So here this opposing force is directly proportional to x. So again here the proportionality constant is, since spring is represented by the letter k, so here we are writing Fk is equal to, this proportionality constant is k into x. And the next one is, suppose if the spring has displacement at 2 points, again I am having a spring, and here we are giving some force, and because of this force, the spring is said to have two displacement. Let the first displacement be x1 at this side, and here let the displacement at this side be x2. Then how can we write this force balance equation? So again, the force balance equation is written as Fk is directly proportional to, here the displacement is only 1, so we are directly making it as directly proportional to the displacement x. Here whereas in the case we are having two displacements x1 and x2, so this opposing force is directly proportional to the difference between x1 and x2. So finally we can write it as Fk is equal to, again here the proportionality constant will be k, so k into x1 minus x2, right? And the last one is, we are going to discuss about dashpot. So regarding again, just consider a dashpot here, and this dashpot is connected to some reference point. So again it is represented by the letter B, and here the given force is F. So automatically the opposing force produced by the dashpot will be in the opposite direction. So we are representing here as FB, and the displacement is x. So how we can represent the opposing force given by this dashpot is, this Fb is directly proportional to the velocity, that is dx by dt. Again, whenever we include the proportionality constant, this expression gets reduced as Fb is equal to b times of dx by dt. Right. And finally, again, when the dashpot has displacement at both ends, the same thing, just consider the dashpot B. It has displacement, that is, let the initial displacement be x1 and then this same displacement be x2, and here this is the applied force F, and automatically this is the opposing force which is given by Fb. So here in this case again Fb is directly proportional to, here we are having two displacement x1 and x2, so here we are again including the distance, that is difference between the two displacement, d by dt of x1 minus x2. Now again when we include the proportionality constant, so Fb is equal to b into d by dt of x1 minus x2. And again this opposing force produced by this dashpot is always equal to the applied force. So here again F is equal to Fb, and again we will be having this same expression. Similarly here also this F is equal to Fb. Whatever may be the case, the main thing which we should consider in our mind is this applied force will be always equal to the opposing force. Right. So in this video we have discussed about what is a mechanical translational system and what are all the basic elements which we are using in a mechanical translational system, and how to express the force provided by this elements, that is basic elements, mass, spring and dashpot. Thank you.